Hi everyone, I am Amin Agadir from Electronic Signal Processing and Physical Modeling. I am so glad to participate in this conference. My participation is about high spatial resolution effect on ozone pollution modeling, case study of Morocco, Agadir city. The outline of this presentation is as follows. First, I start with an introduction on air pollution. Then, I moved on the methodology of this work. After, we discuss the result obtained by this study. At the end, I will finish with a conclusion. According to the World Health Organization, the effects of outdoor and indoor air pollution result in approximately 7 million early deaths each year. According to the same organization, both long and short-term exposure to the toxic substances in the air have several toxic impacts on humans, especially respiratory and cardiovascular disease. Most studies conclude that air pollution harms the ecosystem and especially the human health. In the case of Morocco, the economic cost of atmospheric pollution in 2018 has been estimated at 1.62% of the country's GDP. According to the Moroccan Secretary of State for Sustainable Development, this significant number has encouraged Morocco to devote special effort to fight against air pollution. For this reason, the first campaign in Morocco started in 1997 and in Agadir in 2010. Now I switch to the methodology of this work. The modeling part carried out using three models based on weather research forecast data. The shimmer model calculates the gas and aerosol concentration. The weather research forecast model is used to compute meteorological data. Finally, the emissive model provides gas and aerosol emissions. The evolution equation of a chemical species concentration can be decomposed as the number of individual factors which can be determined directly or indirectly. There are two numerical methods. The first considers the problem as a whole integrated all of the trend. The second is the method of separation operator. The equations governing the phenomenon of air pollution can only be resolved analytically for a few simple cases. However, they account for nonlinear and coupled differential equations that explain diffusion, advection, and chemical reactions. A numerical resolution that meet the boundary conditions is needed. The finite volume approach was used in the Chimere model. The need for stability, and as a result, a reduction in computation time drives the decision to use such methods. The figure 1 depicts the selection of two meteorological domains for this study, the main domain D01 in red and subdomain D02 in black, both of which cover Moroccan territory. The weather resource subdomain in turn contains the shimmer simulation domain in yellow, which includes a portion of Morocco. All of these domains describe Moroccan's geographical diversity, including the desert, mountains, and oceans. In the Shimmer model, the first approach is used and the time integration is based on two-step algorithm. The calculation is performed on the application of a Gauss-Seidel iteration scheme to the two-step implicit backward differentiation formula. As a dangerous pollutant, ozone plays a significant role. The study of this pollutant allows us to collect a range of data. These tables summarize the model statistical scores when simulating ozone. A first look leads one to the fact that, in contrast to summer, spring provides statistical relevant values for both seasons. In terms of mean fraction error and mean normalized error, the spring has a lower mean error of 17% than the summer, which has a value as high as 20%. The model overestimates the ozone concentration in all seasons and resolution in this report. C3 is more consistent with the observed data at the season mean level as compared to C1. Figure 2 shows comparison of monthly ozone time series between observation and the two scenarios C1 and C3. This figure shows that the model overestimates overall ozone concentration in both seasons. There is also a difference in estimation due to the type of resolution used, ranging from a maximum absolute value of 3 microgram by meter cube in June to the minimum of 0.8 in April. Figure 3 shows nitrogen dioxide concentration in May, which corresponds to the spring season, and July, which corresponds to the summer season. Summer tend to have a lower NO2 level than spring, particularly at the start and the end of the day, which support the maximum and minimum mean bias observed in the same season. In general, NO2 becomes the deciding factor in some ozone chemistry situation, so reduction surface nitrogen oxide will result in the slight increase in ozone. The model performance is acceptable as compared to the other finding. However, other research find opposite ozone result. In this study, we looked at the performance of two scenarios. We compared the numerical findings to ozone monitoring data collected on the ground during the spring and summer of 2010. Three deterministic models, Shimmer, Weather Research Forecast, and IMSURF, were used to simulate the city of Agadir in Morocco. The results show the resolution used affect modeling efficiency. Using a high resolution for ozone offers more details. The probability of achieving a good correlation is increased with high resolution. It appears that the large mean bias observed is related to the low nitrogen dioxide concentration seen in the spring. Scenario 3 is the best ozone model, especially in the spring when the model can accurately capture the real pattern. Thank you, and I hope you are doing well.